number 7. Using the definition of the derivative, find f prime of x, then find f prime of 1, f prime of 2, and f prime of 3 when the derivative exists. So this is a polynomial function. It has no denominators. It has no square roots. And it has no logs. So that means it's continuous everywhere. So for all x, and it has a derivative for all x. So definitely we'll be able to find the derivative at 1, derivative at 2, and the derivative at 3. Now the definition of the derivative, f prime of x, is the limit as h goes to 0, f of x plus h minus f of x over h. And we do this generically without putting in a value for x, and then we can easily use the formula we get to find f prime of 1, f prime of 2, and f prime of 3 just by substitution. Now we always start finding the derivative by doing f of x plus h, and we're going to have to be careful here because there's a minus outside of the square. We need to keep it there. And then I'm going to substitute in these parentheses, I'm going to put x plus h. So be careful. You've got to square first, x squared plus 2xh plus h squared, and there's a minus outside of that. We're going to apply that last, plus 5x plus 5h plus 7. So that's the opposite, or negative x squared, minus 2xh minus h squared plus 5x plus 5h plus 7. So that's just the f of x plus h part, and it's usually the hardest part. Now from this, we're supposed to subtract the original function. So the opposite of f of x. Okay? Well, that's going to be a positive x squared, a minus 5x, and a minus 7, because I'm taking the opposite of all of these because this says subtract them all. So what happens is every time you do this, the original function terms should go to 0 because you're taking out all of the original function terms, and what's left should have an h in every term if it's done correctly. So we have an h left in all of those terms. Now we're supposed to take this and divide it by h. So I'm going to divide each of these by h. And those are going to reduce to minus 2x minus h plus 5. And as soon as I take the limit of this, the limit as h goes to 0 of this formula, minus 2x minus h plus 5, I then have the formula for the derivative, or the instantaneous rate of change, for any value x on this function. So that's going to be a minus 2x, a minus 0 plus 5. So my formula is minus 2x plus 5. So that is my derivative, minus 2x plus 5. Now, some of you have taken this course before or taken another calculus class may recognize that there is a shortcut for this, but we're going to do it by formula first, and then we'll talk about the shortcuts a little bit later. So now that I have the formula, I can do f prime of 1 by substituting a 1 for x. I can do f prime of 2 by substituting a 2 for x, and I can do f prime of 3 by substituting a 3 for x in the derivative formula. So f prime of 1 is negative 2 times 1 plus 5. That's negative 2 plus 5 is 3. F prime of 2 is negative 2 times 2 plus 5. That's negative 4 plus 5 is 1. And f prime of 3 is negative 2 times 3 plus 5 is negative 6 plus 5. It is negative 1. So f prime of 1 is 3, f prime of 2 is 1, and f prime of 3 is negative 1.